Losing your eyesight is an emotional nightmare. It's a living nightmare. My name is Desiree Roberts. Shortly before my 44th birthday, I was a self-employed single mom, living the good life. 3 months later, I started to notice a change in the vision in my right eye. And a week before Christmas, I lost the rest of my sight.
My son was 4.5, and it came to us, his biological mother, we had information that she might be a carrier of X-linked RP. He had a 50-50 chance of getting the disease, and unfortunately he fell on the one side, but I believe it's a fortunate thing. My son is the most courageous human being I ever met. At 13 years old, that kid lives every single day like he's the last day he's going to be able to see.
The day that I was told the damage to my retinas was permanent was a tragic day in my life. You know, there's no hope.
It's one thing to have a visual disorder, which is hopeless, and another thing to have a visual disorder for which is no treatment, but for which is hope. And the role of this institute is to provide that hope.
We do a lot of work on a very prevalent disease called age-related macular degeneration. This affects about 1 in 5 people over age 75. There are other diseases that affect often younger people, like retinitis pigmentosa. It can cause blindness that gradually increases over decades of life. It's a really exciting discovery that we made over the last several years. We found out that the human retina contains a new type of stem cell, the retinal pigment epithelial stem cell.
With the retinal pigment epithelium, as humans age, they start to break down and start to secrete certain proteins that are related to this disease called age-related macular degeneration. And so in this lab, a number of scientists have developed a stress model which replicates this disease in terms of expression of proteins.
We set up this system where we can model some of the eye disease like age-related macular degeneration and create this disease in a dish. And now that we have this, we can test for drugs and small molecules that can block the disease or lower the disease. The aim here is to try to cure the disease.
We've discovered that the cell can be activated in the culture dish, and it can be grown up and make brand new healthy cells. The question is, could we actually do that in the eye? Could we activate it in situ to repair? So the idea of really using that dormant cell and reawakening it, and then having it repair itself, as it were, that is something that we're working on.
If the stem cells are identified and damaged retinas can be fixed, then absolutely no one has to go through what I went through, or that I go through every day.
We are passionate about translation. That is, bringing therapies from the bench to the bedside. Everything that we do here is geared towards that. We believe and are really passionate about basic research, but our big drive here is to bring those discoveries that we make in the lab towards the patient for patient benefit.
The concept that we can take those factors and apply them inside the eye without any surgery has not yet been developed fully. It's a little far-reaching for grant applications. We haven't found funding for that yet.
I believe that the only way to find a cure is to raise money and to fund science, innovative research. And what I've seen here at this place is incredible. People have passion, people care. And if you have passion, you can achieve anything.
The RPE stem cell was discovered through a donation. That is a great example of where a donation truly allowed us to make a leap forward into brand new territory that we didn't even imagine until that donation came in.
I firmly believe, until the last breath I draw, we will raise money and we'll have a cure, one way or another. And I'm just glad that this organization takes the time to talk to me about this disease. Whereas many bigger organizations, it would be lip service. Not here. This is real, and we will find a cure.